Do you think time travel will ever be possible?
Not into the past. So into the future, yes. There's a calculation in one of my books with Jeff where we work out. So if you travel at 99.9999999, that's 8 9% the speed of light to Andromeda, which is 2.5 million light years away, and then turn around and come back again, then for you on the rocket, 100 years will have passed on the round trip journey, but 5 million years will have passed on Earth. So by traveling fast relative to people who are stationary, your clock runs slow relative to theirs. So you can travel into the future arbitrarily far into someone else's future without. You just do it. That we know that works. But into the past, it's true to say that, as you know, that Einstein's theory of general relativity, his theory of gravity, allowed you to curve space and time. So what I'm talking about there with traveling to Andromeda back is what's called special relativity. So it's flat space and time, and that you definitely cannot go into the past in special relativity if space is flat. But if you're allowed to curve space-time, then there are solutions to Einstein's general theory of relativity that allow you to build wormholes, which would allow you, in principle, to take shortcuts around. So although you can't exceed the speed of light and therefore get into the past on the surface, it's like going to Australia but going through the Earth rather than going around the edge. So you can take a shortcut. So you can, in principle. I believe most physicists who work on quantum gravity think that there won't be stable wormholes in a quantum theory of gravity, but that's not proved as far as I know. So as far as I know, there's a loophole.
Because we don't have a proper quantum gravity theory.
Yeah. So but I mean, most people, because the thing traveling to the past doesn't seem to be the right way to build a universe. And indeed, in general, the universe seems to be built such that you can't do that. Interestingly, though, when I said about the electron that can be anywhere in the universe, it's not only anywhere spatially, it's temporally as well. So in what you do in Feynman's path integral approach is integrate over space-time. So you allow it to do all paths, including paths in the past. Right, that's what the way it works, but they all cancel out. But that seems to be a calculational thing.